A 1.25 gram sample of limestone was added to 50 milliliters of 1 molar hydrochloric acid. When reaction stopped, solution was made up to 250 milliliters with distilled water. A 25 milliliter sample was pipetted into a conical flask and titrated with 0.1 molar sodium hydroxide in presence of methyl orange indicator. It required exactly 30 milliliters. Determine the percentage calcium carbonate in the sample. Now, this is called back titration because we work in the opposite direction. We start with the second reaction and it's going to give us ideas about the first reaction to determine everything about it. Now, starting from this point, we've been given a 25 milliliter sample. So this sample is coming from the first reaction. When the first reaction occurred, calcium carbonate reacted with 2 moles of hydrochloric acid. The hydrochloric acid is in excess. That is why we can see it in the first reaction. So when the first reaction occurred, a 25 milliliter sample was gotten from that. So now this 25 milliliter sample, we reacted it with 0.1 molar sodium hydroxide, and then it required exactly 30 milliliters. That 30 milliliters is giving us the volume of sodium hydroxide that we used. First thing that we are going to find here is the number of moles of sodium hydroxide. Now notice that these are in a mole ratio of 1 to 1. So the number of moles of sodium hydroxide are equal to the number of moles of hydrochloric acid. So the number of moles of hydrochloric acid, this is in what? In 25 milliliters, because it's the 25 milliliters which we reacted with sodium hydroxide. So the number of moles of hydrochloric acid in 25 milliliters is equal to the number of moles of sodium hydroxide, and this is equal to concentration times volume. So what we are going to use is this. Concentration of sodium hydroxide times its volume is going to give us the number of moles. So the concentration, of course, this is 0.1. Now molar is mole per liter, and we are multiplying it by 30 milliliters. Now we need this, we can see this can't cancel out. We need to make sure that those units cancel. So I'm going to convert the milliliters to liters. So because we have got a milliliter on top, we want it to go to liters, we're going to bring it down. And then we want it to go to liters. And we know that in 1 liter we have got 1,000 milliliters. And so this is going to give us 0.003 moles of hydrochloric acid. So these are the moles of hydrochloric acid which are present in 25 milliliters. Now, if we read this, when this reaction occurred, as we can see, when reaction stopped, the solution was made up to 250 milliliters with distilled water. And this one which we've made up to 250 milliliters is like when the reaction is occurring. After the reaction was complete, we added water and we reached to 250 milliliters. Now, the whole of this, we only got a portion. We only got 25 milliliters. That's the one we reacted. So we need to first find the number of moles which are in 250 milliliters, because it is from this that we only got a portion of 25 milliliters. Okay, so the number of moles of hydrochloric acid in 125, okay, that is 250. In 250 milliliters is going to be equal to, we are just going to multiply by the number of moles of hydrochloric acid in this 25 milliliters, which is 0.003 moles, and then we are going to multiply by 250 over 25. So all we are saying is how many 25s are in 250. Okay, how many 25s are in 250? And that how many they are, we multiply by the number of moles, because if this volume, if a 25 milliliter volume had 0.003 moles, how about the actual one from where we got the 250 milliliters? How many moles is it going to have? So we are just finding how many 25s are in 250, and then what we find, we multiply by 0.03. Okay, and so notice what I've written there is because the 250 is in milliliters, the 25 is in milliliters, so milliliter over milliliter, we're just going to have a number there, and so that is going to give us 0.03 moles of hydrochloric acid. All right. Now, these are the moles of hydrochloric acid which are present in the 250 milliliters. We need also to find the number of moles of hydrochloric acid which were there initially. Now, the initial moles have been given from here. So, number of moles of hydrochloric acid initial is going to be equal to the concentration times the volume. Now, the concentration we've been given is 1 mole per liter. The molar we can see is the same as mole per liter, and then times 50 milliliters. Now the milliliters we convert to liters. In 1 liter we've got 1,000 milliliters. So this is going to give us 0.05 moles of hydrochloric acid. Now what is happening here is, when we reacted calcium carbonate with hydrochloric acid, we reacted it first with these moles of hydrochloric acid. Okay. Now notice that in the second reaction, everything that remained in the first reaction reacted in the second reaction, and in the second reaction only 0.3 reacted. That means how many reacted in the first reaction? These moles we've been given are what was there present at the start. These are the ones which were present in the which reacted in the second reaction. So even if these are the ones present at the start, they are not the ones which reacted. The ones which reacted, it is these which were present at the start minus what reacted in the second reaction. Okay, so we're going to find the number of moles of hydrochloric acid which react in the first reaction. So say number of moles of hydrochloric acid that reacted, this is in the first reaction, is going to be equal to number of moles of hydrochloric acid initially minus the number of moles of hydrochloric acid which are present in the 250 milliliters. Remember, it is the 250 milliliters from where we got this portion, and then this portion, the one which reacted now, is sodium hydroxide. Okay, so this is going to give us number of moles initially is 0.05. The one which were present in 250 milliliters is 0.03, and this is going to give us 0.02 moles of hydrochloric acid. So these moles of hydrochloric acid are the ones which reacted now with calcium carbonate. Now from the mole ratio you can see that number of moles of calcium carbonate over 1 is equal to number of moles of hydrochloric acid over 2. And so to find the number of moles of calcium carbonate which reacted, we'll just get the number of moles of hydrochloric acid which we can see there as 0.02, and then divide by 2, and that is going to give us 0.01 moles of calcium carbonate. Now let's convert these moles to mass. We know that so the mass of calcium carbonate is equal to number of moles times molar mass. So the number of moles is 0.01. The molar mass of calcium carbonate is 100.09, and this is going to give us 1.000 grams of calcium carbonate. So this is the mass of calcium carbonate which reacted. Now notice that we were given this much, the sample of calcium carbonate which was given at that mass, and only this reacted. That means there was some impurity. So the percentage of calcium carbonate in the sample, is going to be what reacted over the total sample that we are given, that is 1.25, and then multiply by 100%. So that is going to give us 80%. So that is the mass, that is the percentage of calcium carbonate in the sample. Secondly, we've been given a question. A 1 gram sample of potassium carbonate with that molar mass is dissolved in enough water to make 250 milliliters of solution, and then from that we get a 25 milliliter alloquent. That is just a portion, and then we titrate it to 0.1 molar hydrochloric acid. Now I want to find how many milliliters of hydrochloric acid we used. First thing we want to find is the number of moles. So for this one we just have one reaction, as we can see. So what we are having is potassium carbonate reacting with hydrochloric acid. This is a balanced reaction to produce 2 potassium chloride plus water plus carbon dioxide. Okay. Now there's only one reaction, and then we've been given the mass of potassium carbonate as 1 gram, and then for the hydrochloric acid we've only been given, what have we been given about hydrochloric acid? 25 milliliter of this solution is taken and titrated. We've only been given the concentration as 0.1 molar. Now I want to find the volume. Now the first thing we are going to do with the potassium carbonate, of which we've been given a lot of information. So number of moles of potassium carbonate is equal to mass over molar mass. Now the mass of potassium carbonate has been given as 1 gram. The molar mass is given there as 138.2055 grams per mole. And so if we divide this, we are going to find 0.007356 moles of potassium carbonate. Now a 0.1 gram sample is dissolved in enough water, so these moles we are going to dissolve them in 250 milliliters of water, okay, to make a solution. So if we dissolve them, we can find the concentration. So the concentration, which is also the molarity of potassium carbonate, is given by the number of moles over volume. Now the number of moles we've already found as 0.007356 moles over the volume. The volume has been given as 250 milliliters. To convert milliliters to liters, just multiply by 10 to the power negative 3, and then it is now in liters. So the molarity for this solution is going to be 0.028942 molar. Okay. Now after we dissolved in water, we only got 25 milliliters, and the 25 milliliters is what we reacted with a second reaction. So from this concentration we are only getting this volume. Remember the actual volume is 250, but we're only getting a 25 milliliters. So we're going to say what's the number of moles now of potassium carbonate if we get that volume. Number of moles is molarity times volume, just from this same formula which we have here. So we've already found the molarity because it's from the same solution that we are getting a portion. So the molarity is the same. So that is 0.02894 molar, which is mole per liter. And then we are multiplying by that certain this volume that we are getting. We only getting 25 milliliters. So that is times 25. Now this 25, it is in milliliters. We need to convert it to liters. So to convert it to liters, we are going to just divide by 1000. Now dividing by 1000 is the same as multiplying by 10 to the power negative 3. That is what we are saying, that if you want to convert from milliliters to liters, just multiply by 10 to the power negative 3 or divide by 1000. And so that is going to give us 0.00072356. These will be the moles now. Okay, so those are the moles. Now it is these moles which reacted now with the hydrochloric acid. Now from the reaction we can see number of moles of potassium carbonate divided by 1 is equal to number of moles of hydrochloric acid divided by 2. From the mole ratios we can see. Now the number of moles of potassium carbonate we've already found as 0.007356 moles, and this should be equal to number of moles of hydrochloric acid over 2. So to find the number of moles of hydrochloric acid, I'm just going to multiply 2 by that value which is here, and that is going to give us 0.00144712 moles of hydrochloric acid. Now I want to find the milliliters of hydrochloric acid. That means we want to find the volume. So now if we have got the number of moles and then we've been given the concentration, we can find the volume. We know that concentration is number of moles over volume. If we make V the subject the formula, volume is going to be given by number of moles over concentration. The number of moles is 0.00144,712 moles, and then the concentration we've been given 0.1 molar. 0.1 molar is in mole per liter. So these moles are going to cancel, are going to remain with liters, and so the value we are going to have is 0.0144712. Now this value will be in liters. Now the question is asking for milliliters of hydrochloric acid. So to convert this, when we are converting from milliliters to liters, you multiply by 10 to the power negative 3. When you are converting from liters to milliliters, just multiply by 10 to the power positive 3. And this is going to give, the decimal point is going to move 3 times. 1, 2, 3. So that will be 14.47 milliliters of what? Hydrochloric acid. So that would be the answer in that case. Another question here. A 0.600 gram sample of potassium carbonate is dissolved in enough water to make 200 milliliters of solution. A 20 milliliter eloquent of solution A is taken and put into a flask. To the flask is added 20 milliliters of 0.17 molar hydrochloric acid. The resulting solution is then titrated with 0.1048 molar sodium hydroxide. How many milliliters of sodium hydroxide are used? Now we need to understand the equations which are happening. The first thing is we are reacting with potassium carbonate, okay, with hydrochloric acid. So the reaction there, of course, already given is potassium carbonate plus 2 moles of hydrochloric acid. That is going to give us 2 moles of potassium chloride plus water plus carbon dioxide. And then the second reaction, everything that remained, the hydrochloric acid that remained, we are already given this reaction, so we don't need to worry about them. Of course, we can even make them even if we're not given. And this is sodium chloride plus water. Okay, so this is the information that we have. Now, this being back titration, let's work in the backward manner. So the first thing is we're going to do with the second reaction. In the second reaction, what do we have? We've been told after the first reaction occurred, okay, the reaction in the first reaction, we added, first before even the reaction occurring, we just put 0.6 gram sample of potassium carbonate in a certain vessel, and then we added water to make that much volume. Now that much, we only got a portion, and this portion we reacted it, or we mixed them with hydrochloric acid. Now after we mix with the hydrochloric acid, what remained here, because one of these is in excess, one of them is limiting. The hydrochloric acid, because we can see it in the second reaction, that means it's the one which was in excess. So the hydrochloric acid now was mixed with, was reacted with another thing, was reacted with now sodium hydroxide. We only know the concentration of sodium hydroxide. Okay. Now we want to determine the milliliters of sodium hydroxide which were used. So now the first thing we want to find is, if we go to the second reaction, of course we know that the concentration of sodium hydroxide is 0.1048 molar. We don't know the volume. That's the one we've been asked to find. So we are going to say number of moles of hydrochloric acid. As you can see, these are in a mole ratio of 1:1. Should be equal to the number of moles of sodium hydroxide. And how do you find that? It's by concentration times volume. Now, the number of moles of the concentration of sodium hydroxide is 0.1048. And then we're going to multiply by the volume which we don't know. So this concentration times volume will give us the number of moles of sodium hydroxide, which is equal to the number of moles of what? Hydrochloric acid. So these are the moles. Okay. Now remember, this, what has happened here is, this happened, we only got a 25 milliliter of solution A. Solution A is potassium carbonate, which we dissolved first in 200 milliliters, and then we only got that portion. Now the hydrochloric acid that we added in this case, if we can see, the hydrochloric acid that we added 20 milliliters of 0.17 hydrochloric acid. So from this, what we have, we can also determine the number of moles of hydrochloric acid which were there initially. Okay. So to determine that, anyway, before we even do that, we are going to first go to the first reaction, because we've been given some ideas. We can determine the number of moles of first the potassium carbonate. So number of moles of potassium carbonate is going to be equal to mass over molar mass. So the mass is 0.6 grams. The molar mass is 138.2055 grams per mole. And this should give us 0.00434136 moles of potassium carbonate. Now these moles, remember, we dissolved them in 200 milliliters. So let's determine the concentration. Concentration is number of moles over volume, and the number of moles is 0.00434136 moles. And then we dissolve them in 200 milliliters. We want to convert the milliliters to liters by multiplying by 10 to the power negative 3. And that is going to give us 0.0217 molar of potassium carbonate. Now to this, from this concentration, we only got a portion, we only got 20 milliliters. So now what we are going to do is we are going to find how many 20s are in this volume which is here, and then how many they are. We are going to multiply with the concentration which you found. Anyway, before we even do that, we can actually just go direct for this one. Since we know the concentration, now it is from this concentration that we only got this portion of volume. So to find the number of moles of potassium carbonate in only that 20 milliliters is going to be equal to the concentration times the volume. Now the concentration is the same because we've gotten from the same solution, so it's 0.217 molar is mole per liter. And then we are multiplying. Now we only want to find the number of moles in 20 milliliters. So multiplying by 20, now that is in milliliters, we multiply by 10 to the power negative 3 to convert to liters. And that is going to give us 0.00434136 moles of potassium carbonate. Now it is these 20 milliliters that we put into this flask, and then to this flask, that is now where we added hydrochloric acid. So it is actually these moles which reacted with hydrochloric acid. Now remember, the hydrochloric acid was here and is also here. That means the hydrochloric acid is in excess. So this is the one which was limiting. Okay. So since we have the number of moles that we are limiting, so at this point I can remove this. So using this number of moles of potassium carbonate which reacted, we can determine the number of moles of hydrochloric acid which reacted in the first reaction. So number of moles of potassium carbonate, as we can see from the first reaction, over 1 should be equal to the number of moles of hydrochloric acid over 2. So determine the number of moles of hydrochloric acid. That is going to be 2 times the number of moles of potassium carbonate, which is 0.00434136 moles. And this is going to give us 0.00086827 moles of hydrochloric acid. So these are the moles of hydrochloric acid which actually reacted in the first reaction. Okay. Having found the number of moles of hydrochloric acid which reacted in the first reaction, we've been given 20 milliliters of 0.71 hydrochloric acid. So those are the initial moles. So number of moles of hydrochloric acid. Of course, these are the ones which reacted in the first reaction. Number of moles of hydrochloric acid initially is going to be equal to concentration times volume. Now the concentration is here, 0.17 mole per liter. That's the meaning of molar. And then times the volume was 20. So times 20 times 10 to the power negative 3. I'm just converting the milliliters to liters so that the liter and the liter is going to cancel. So this is going to give us the initial number of moles as 0.0034 moles of hydrochloric acid. Now these were the moles initially, and then these are the moles which reacted in the first reaction. So if we subtract these two, that will give us a number of moles which remained to react in the second reaction. So we'll say the number of moles of hydrochloric acid, so those will be now the one which will be in excess, the one which is going to remain, will be equal to the number of moles of hydrochloric acid initially minus the number of moles of hydrochloric acid that reacted in the first reaction, and that is equal to the initial moles is 0.0034, then minus those which reacted in the first reaction is 0.00086827. Okay. So if we do the subtraction here, we're supposed to get 0.002531.728 moles of hydrochloric acid. Now these are the moles of hydrochloric acid which remain to react in the second reaction. And already we saw that in the second reaction, the number of moles of hydrochloric acid were equal to the number of moles of what? Sodium hydroxide, and that gave us this. So that is telling us that the 0.1048V, these are the same moles which are there, which is the 0.002531728. These are the ones which remain to react in the second part, and so they should be equal to the number of moles of what? Sodium hydroxide. So to remain with V, we're just going to divide by 0.104. So 0.1048, even the other side, 0.1048. So punching on our calculators the value that we have there, supposed to find V being equal to, okay, so the volume is going to be equal to, remember this one which we put here was in moles, okay, even the one which is down here is also in moles. So the volume we're supposed to find is 0.0024157709. This volume is in liters. Concentration times volume, always multiply the concentration with the volume that is in liters. Now I want to find the milliliters. So this value we are going to multiply it by 1000. Okay. Why are we multiplying by 1000? That is because if I can just write 0.002415, let me just write this up to this point. This is in liters. To convert it to milliliters, because the liter is on top, we're going to bring the liter down and then milliliter there. A liter, in 1 liter I've got 1000 milliliters. So this is what happens. And so the volume, the decimal point is going to move 3 times. 1, 2, 3 up to that point. Okay, and even my multiplication here was not too true. The decimal point is supposed to move. The value that we are going to find here is 0.0. Okay, just a moment, let me just write this properly. So we are saying the volume is going to be, punching on a calculator properly, that value we are supposed to find 0.0241577, okay, 09, like that. So it is from here that we are saying we are going to, this is in liters, so now we are going to multiply it by 1000 to convert it now to milliliters. So the decimal point moves 1, 2, 3, and so the volume is going to now go into 24.1. So we can just remove a 1 from this one to put on the 5, and then it will be 24.16. That one now will be in milliliters. Alright, so that becomes the answer for that problem. Another question given here, a 0.418108 gram sample of calcium carbonate is added to a flask along with 15 milliliters of 2 molar hydrochloric acid. Been also given the equation. Enough water is added to make 250 milliliters of solution A, and then a 220 milliliter aliquot of solution A is taken and titrated with 0.11060 molar sodium hydroxide. The equation has been given. So I want to find how many milliliters of sodium hydroxide are used. So it is a kind of similar situation, so just something is different on this one because the dilution has not happened on the stage as the previous question. So what we are going to have here is we are going to first find the number of moles. In the second reaction, as we can see, we are going to start with the second reaction. Enough water is added to make 250 milliliters of solution A, and then we only get a 20 milliliters of aliquot of solution A, and we titrate it with that much, 0.1160 of sodium hydroxide. So also we are going to start with the second reaction, and from the mole ratio you can see that number of moles of sodium hydroxide is equal to number of moles of hydrochloric acid. It's in the mole ratio of 1 to 1. So say number of moles of hydrochloric acid is equal to number of moles of what? Sodium hydroxide, and this is going to be equal to concentration times volume. Now the concentration in this case for sodium hydroxide is that, so we're going to say 0.1160. What was the volume of sodium hydroxide? We don't know, so this will give us a moles. So these are the number of moles of sodium hydroxide, and they are equal to the number of moles of what? Hydrochloric acid. Now remember, the hydrochloric acid is the 20 milliliters of hydrochloric acid. So these are the moles in 20 milliliters, okay, of what? Hydrochloric acid. Now we are going to go back. From this we have found the number of moles in 20 milliliters, but remember we first add this thing, we add 25 milliliters of solution A, and then from this 25 milliliters we only got a portion which is a 20 milliliters, and so we're going to find how many moles of hydrochloric acid are in 25 milliliters. So that will be number of moles of hydrochloric acid, sorry, that is in the 250, not 20, that is in 250 milliliters, and that will be equal to the same number of moles of hydrochloric acid which are present in 20 milliliters. Now we're going to multiply by 250 milliliters over 20 milliliters. All we are doing is we are saying how many 20s are in 250. If we find how many they are, then if we multiply that by the number of moles in 20, then we are going to find the number of moles in what? 250. And that is supposed to give us, okay, if we do the multiplication, we are going to find 1.45 V moles. Those will be the moles of what? Hydrochloric acid present in 250 milliliters. Okay, after dealing with this, we can pause at this point since we can't go further. Let's go to the first reaction. We've been told a 0.410 gram sample of calcium carbonate. We can first find the number of moles of calcium carbonate. So the number of moles of calcium carbonate is given by mass over molar mass. Now the mass given is 0.4108 grams. The molar mass is also there, 100.087 grams per mole. So dividing this, we are going to find 0.004104429 moles. This is of calcium carbonate. Okay. Now, what we can see here is, look at the reaction. Remember, hydrochloric acid is in excess. So, that means the calcium carbonate will be all used up. All these moles are going to be used up because it is the limiting reagent. How did we tell that hydrochloric acid is in excess? That is because we can see hydrochloric acid even in the second reaction. Obviously, it is the one in excess. So using the first reaction, number of moles of calcium carbonate over 1 is equal to number of moles of hydrochloric acid over 2 because of the mole ratio. So that is, okay, we write that number of moles of calcium carbonate over 1 is equal to number of moles of hydrochloric acid over 2. But we want to determine the number of moles of hydrochloric acid. So just multiply 2 by the number of moles of calcium carbonate. So that will be number of moles of hydrochloric acid is equal to 2. Now the number of moles of calcium carbonate we've already determined as 0.004104429. And this is supposed to give us 0.0082 08858 moles. This is of hydrochloric acid. So these are the moles of hydrochloric acid which have reacted in the first reaction. Okay, these are the moles that have reacted with calcium carbonate. Now we can find the initial number of moles of hydrochloric acid. Remember, also not forget this number of moles of hydrochloric acid which are present in what? In 250 milliliters, which is the 1.45 V. Okay. So we can go on and find the initial number of moles of hydrochloric acid. So number of moles of hydrochloric acid initially is going to be given by concentration times volume. So we've been told from here 15 milliliters of 2 molar hydrochloric acid. That is the one which was first put. But of course, even if that was put, it's not everything that reacted. So the concentration is 2 molar, which is 2 mole per liter, and then times the volume that is been given as 15. Now that is in milliliters, so converting that into liters, we multiply by 10 to the power negative 3. So that would now be in liters. So that is going to give us, of course, 2 times 15 is a 30. So that is going to be about 0.03 moles of hydrochloric acid. So these are the initial moles. These are the moles which reacted in the second reaction. So how many moles are left to react? I mean, these are the moles which reacted in the first reaction with calcium carbonate. Now, how many moles are left to react in the second reaction? So number of moles of hydrochloric acid which were in excess are the ones which reacted in the second reaction is equal to the number of moles of hydrochloric acid initially, and then minus the number of moles of what? Hydrochloric acid which reacted in the first reaction with calcium carbonate. Now the initial number of moles of hydrochloric acid we've already found 0.03. Those which reacted with calcium carbonate we found 0.008208858. So what value are we going to find here? So that will be 0.021791141 moles. of hydrochloric acid. So these are the ones in excess, and the excess number of moles are the ones which came to react in the second reaction with sodium hydroxide. And you've just seen that the number of moles of hydrochloric acid which reacted with the sodium hydroxide are those. Okay, because we found that number of moles of sodium hydroxide was equal to the number of moles of hydrochloric acid. So we expect the 1.45 V to be equal to 0.021791141 to be equal. So now our aim is to remain with V. So we are going to divide by 1.45. Even the other side divide by 1.45. So the V we are going to find at this point is going to be 0.015038373. Now this will be in liters. Okay. Our aim is to find the milliliters of sodium hydroxide. So these are the moles of sodium, the volume of sodium hydroxide you found. Remember, when we are doing the multiplication, we multiply the concentration times the volume of sodium hydroxide. Now to convert this volume to milliliters, all we do is volume is 0.01503. Okay, 8. I can just multiply this by, okay, there is a certain value here, there is a 2 which I've left out writing. There is a 2 behind there. We can punch on the calculator to confirm that. Alright, so this is in liters. Now I want to convert to milliliters, so multiply. Want a liter down so that it can cancel out with this, and then a milliliter here. You know that in 1 liter we've got 1,000 milliliters, so this decimal point is going to move 1, 2, 3. It is going to go up to there. So the volume is going to be then 15.03. So I'm saying there should be a 2 here. So it will be 15.03 milliliters. If it is not a 2 there, then I'm mistaken. It should be somewhere, but that's the, okay, that's the answer then. If I have not written it properly, I don't know if the 2 is supposed to be in front or behind, but one of those you can check out through. You can punch this on the calculator to check that through. Another question given here. A 0.6181 gram sample of M2CO3 was taken and dissolved in enough water to make 100 milliliters of solution A. And then a 10 milliliter alloquent of solution A was taken and mixed with 25 milliliters of 0.1842 molar hydrochloric acid, as you can see by the reaction. Now it took 19.90 milliliters of 0.1473 milliliter sodium hydroxide to titrate the resulting solution. Okay. Now what is metal M? So what will be this metal M? Such that when you react it with hydrochloric acid with all this information, we are going to see it happen. So now we are going to also work in the back direction. The first thing that we want to find is, let's go to the second reaction. We know that these are reacting in the mole ratio of 1 to 1 in the second reaction. 1 mole of sodium hydroxide, 1 mole of hydrochloric acid reacting to produce water and hydrochloric acid. And sodium chloride. So number of moles of hydrochloric acid supposed to be equal to number of moles of sodium hydroxide. And how do we find that? That is by concentration times volume. Now the concentration of sodium hydroxide has been given as 0.1473 mole per liter, and then times the volume we've been given as 19.90 milliliters. So convert this to liters. So to convert it, just multiply by 10 to the power negative 3. It would have gone into liters. So now if we do the multiplication at that point, we're going to find 0.00293127 moles of hydrochloric acid. Remember, these moles of hydrochloric acid we found. Of course, we first found the number of moles of sodium hydroxide, but we know the number of moles of sodium hydroxide are equal to the number of moles of hydrochloric acid. So it is all the same. Okay, having found this, now we can find the number of moles of hydrochloric acid present initially. Okay, we've been given that 25 milliliters of that hydrochloric acid was added. So you can find the initial number of moles of hydrochloric acid. So the number of moles of hydrochloric acid initial is equal to concentration times volume. The concentration is 0.1842 mole per liter, and then the volume is given as 25. We convert that to liters by multiplying by 10 to the power negative 3. So that is going to give us 0.004605 moles of hydrochloric acid. Now just look at this. These are the number of moles of hydrochloric acid which react in the second reaction. These are the initial moles which are given. Now what are the moles which reacted in the first reaction? So to find the number of moles of hydrochloric acid which reacted in the first reaction is to be equal to the number of moles of hydrochloric acid initially. Okay. So initial number of moles of hydrochloric acid minus number of moles of hydrochloric acid that reacted in the second reaction with what? Sodium hydroxide. So the initial ones we've already found, that is 0.004605. And then in the second reaction, those which reacted with sodium hydroxide, we've already found as 0.00293127. So if we do the subtraction, we're supposed to find 0.00167373 moles of what? Hydrochloric acid. So these are the moles of hydrochloric acid which did react in the first reaction. Okay. Now we need to pay a little bit of particular attention here. Alright, so we can find first the number of moles of this metal here. Of course we don't know if it's a metal or what, but all we know, this compound M2CO3, from what you can see here, this compound is reacting with 2 moles of hydrochloric acid. It means if we have the number of moles of hydrochloric acid which reacted, we're able to find the number of moles of this compound which reacted. So the number of moles of this compound M2CO3 over 1, from the mole ratio you can see, should be equal to the number of moles of hydrochloric acid over 2. So this will give us the number of moles of this compound M2CO3 to be equal to the number of moles of hydrochloric acid, which is 0.00167373. We divide then that by 2, and that is going to give us what? 0.00836865 moles. So these are the moles of that compound, okay, which were present. Now look at this. These moles which you've written here, if you look at the question, we only got 10 milliliters of this compound was dissolved in water, and then we got 10 milliliters. So these moles which reacted with hydrochloric acid are present in what? In 10 milliliters. So in 10 milliliters. Now that we know the number of moles which are present in 10 milliliters, these 10 milliliters, we only got them from a portion of what? 100 milliliters. So we need to determine the number of moles of this compound in 100 milliliters from where we got them, because we got that portion and then the portion we reacted with hydrochloric acid. So determine now the number of moles of this compound M2CO3. Okay, so this one we've already said it is in 10 milliliters. Anyway, we can first convert, since we know that it was present in 10 milliliters, like this, 10 milliliters, we can find the concentration. So the concentration of this our compound is going to be number of moles over volume. The number of moles we've already found as 0.00083685 moles, and we know that these moles were present in what? In only 10 milliliters. So divided by 10 Now we convert this 10 to liters by multiplying by 10 to the power negative 3. And that is going to give us 0.08368665 molar. So this is the molar of the compound, the concentration of the compound M2CO3. Now, having determined the concentration, this is the concentration of the compound. Now remember the concentration, this concentration we only got from a portion. I mean, we got from the whole of this, we got a portion of 10 milliliters. So a portion of 10 milliliters gave us this concentration. Now what of the actual one, the 100 milliliters, what was the concentration in that compound? So what we are going to do is, we'll find just the number of moles at this point. So we've already found the concentration, of course. Now we'll find the number of moles then in the other in 100 milliliters. If these are the number of moles in only 10 milliliters of the portion that we got, what was the number of moles in the actual 100 milliliters? So the number of moles is going to be given by concentration times volume. Now the concentration is the same because we got from this portion. If it is from the same portion that we got, then the concentration that we got is all the same. What just changed is the volume. So the concentration is still 0.08365. This is in moles per liter. And then I want to find out the concentration, I mean the number of moles in 100 milliliters. So we're multiplying that now by 100. Now that is 100 milliliters converted to liters by multiplying by 10 to the power negative 3. So that is going to give us 0.0836865 moles in this case. Okay. So these are the moles now of our M2CO3. Alright, now having found this number of moles, have I left out anything here? Okay, there's supposed to be a 0 at this point. Okay, yeah, there is a 0 there which I left out. So those are the number of moles which are present in 100 milliliters. Okay, we found now the number of moles which are present in 100 milliliters. So remember, we got this sample, 0.61 gram of it, and then dissolved it in 100 milliliters. So we are able to determine the number of moles just from this point. If we divide this mass by the molar mass, then that will give us the number of moles. And it is the same number of moles that we dissolved in that volume. So that is the whole idea here. So go on and find the number of moles. Okay. And we know that number of moles is given by mass over molar mass. But we already know the number of moles which we are going to find. It is the same number of moles which we dissolved in 100 milliliters. So these. So 0.008366865, and that should be equal to the mass. The mass is already present there, that is 0.6181 divided by the molar mass. Now the molar mass we don't know because we have got something that is unknown there. So to find the molar mass, that would be simply, this would be over 1. So that would be 0.6181 divided by 0.00836865. So the molar mass of this compound is supposed to be 73.8589562. Remember, its molar mass is in grams per mole. Now I want to find the element M. So what will be this M then? If we know the molar mass of this compound, let's get the compound M2CO3. How do we find molar mass? Molar mass is to get first oxygen. There are 3 oxygens. We multiply by the molar mass of oxygen, which is 15.9994. and then you've got carbon, only one, and then multiply by the molar mass, which is 12.0107, and then you've got this M, which we don't know. There are two of them, so multiply by the molar mass of this thing, M2. Okay, we don't know the molar mass because we don't know the compound itself. So at this point, if these two are numbers, we can find the value here and find the value here, and then we are going to add them. So if we add these two, we are going to find 60.0089. So that is 60.0089, and then plus, we are also adding this plus 2 mr, which we don't know because we don't know the molar mass of this other compound. So that is the sum. Now we know this molar mass that you found here should give us the molar mass that you found from calculation. So what we are saying is the 60.0089 plus 2 mr should be equal to 73.8589 and then 8562. Okay, they should be equal. Now let's go on and determine the value of Mr. The molar mass for it. So we are going to take this, the other side, and then it is going to subtract. So that will give us 2 molar mass is going to be equal to 73.8589 minus 60.0089. We are going to find 13.85008562. Now to remain with Mr, divide through by a 2. So Mr is going to give you 6.92504281, which you can also round off to just about 6.9. Let's say 6.95 grams per mole. Now we need to go on our periodic table. We check what element has got this molar mass. And the element on the periodic table that has got a molar mass of 6.9 is lithium. Therefore, the metal M is lithium. Alright. A similar problem, which you can also pause the video and try it out to find the metal M. A 0.9030 gram sample of M hydroxide was mixed with 20 milliliters of hydrochloric acid, and then enough water was added to make 100 milliliters of solution A. Now we get now a 10 milliliter alloquent of solution A, and then titrate it with 17.64 milliliters of 0.05121 molar sodium hydroxide. What is metal M? The same procedure that you've used for the previous question. Let's go on and start with the second reaction, saying number of moles of hydrochloric acid should be equal to the number of moles of what? In the second reaction, we are reacting sodium hydroxide with hydrochloric acid, so it should be equal to the number of moles of sodium hydroxide, and that should be equal to concentration times volume. Now the concentration of sodium hydroxide has been given as 0.05121 mole per liter, and then multiply the volume we've been given as 17.64 milliliters converted to liters by multiplying by 10 to the power negative 3. And so the answer is going to give us 0.000903344 moles of hydrochloric acid. Okay, having found this, these are the number of moles of hydrochloric acid because they're the same. Number of moles of sodium hydroxide and hydrochloric acid are the same. Okay, well, we are fine with that. Now remember, what we have here is a 10 milliliter alloquent of solution. It was taken and titrated with this. So this number of moles that we have found is in what? In 10 milliliters of hydrochloric acid. We only took a portion. Okay, now let's find the concentration of this portion that we took. So the concentration is given by number of moles over volume. The number of moles is 0.000903344 moles. The volume, that is in 10 milliliters, so convert that to liters, and that is going to give us 0.0903344. Now this will be molar because it's concentration, molar of hydrochloric acid. Okay, so this is the concentration. Now remember this, we only took a portion. The actual one was 100 milliliters of solution A. Now from 100 milliliters we only took a portion of 10 milliliters. So now let's find the number of moles in 100 milliliters. So if this is the concentration, it is the same concentration as in 100 milliliters. All that is differing is the volume, and so the number of moles is going to differ. So I'm going to say number of moles of hydrochloric acid in what? In the 100 milliliters is simply going to be concentration times volume. Concentration already found as 0.0903344 mole per liter. Now the volume we're talking about here is 100 milliliters. So convert this to liters by multiplying by 10 to the power negative 3. And that is supposed to give us, okay, that is supposed to give us 0.00903344 moles of hydrochloric acid. So these are the moles now present in 100 milliliters. Okay, now remember this one, the 100 milliliters, a 0.90 gram sample of M hydroxide was mixed with 20 milliliters of that thing and enough water added. Okay, so now at this point first we're going to find, let's find the number of moles of hydrochloric acid initially. Now this number of moles that we have found here are the ones which were even present, are the ones which are present in 100 milliliters, and we got from 100 milliliters 10 milliliters and reacted with the second reaction. In other words, this number of moles which we found are the ones which reacted in the second reaction. Okay, now we need first to determine the initial number of moles and then determine how many moles reacted in the first reaction. So number of moles of hydrochloric acid initial is equal to concentration times volume. Now the initial ones where we've been, okay, so we've been told we reacted 20 milliliters of 2 molar hydrochloric acid. So the concentration is 2, molar is mole per liter, and then the volume is 20 milliliters. Convert that to liters by multiplying by 10 to the power negative 3, and what you are going to find is 0.04 moles of hydrochloric acid. Alright, now if this is what reacted in the second reaction, this is what was present initially, how much then reacted in the first reaction? So the number of moles of hydrochloric acid that reacted in this first reaction, okay, and that reacted with what? MOH2 is going to be given by the number of moles of hydrochloric acid initial minus the number of moles of hydrochloric acid that reacted with sodium hydroxide, and that is going to give us 0.04 minus 0.00903344, and so that gives us a value of 0.030966556 moles of hydrochloric acid. Okay, these are the moles of hydrochloric acid which reacted with this compound which we don't know. So if these are the moles which reacted, then actually reacted from the first reaction, from the first equation, we can determine how many moles of that compound reacted. Now we can see that 1 mole of this reacted with 2 moles of hydrochloric acid. So number of moles of M hydroxide over 1 is equal to number of moles of what? Hydrochloric acid over 2. So the number of moles of this compound M hydroxide is actually going to be equal to number of moles of hydrochloric acid is 0.030966556, and then divide that by 2, and that is going to give us 0.015483278 moles Okay, so these are the moles of that compound which did react. And then from the reaction itself, since we've already found the number of moles, look, we've been given the mass, we can determine the molar mass or the number of moles. So number of moles is given by mass over molar mass, and we know that this is supposed to be the same number of moles, okay, which this is supposed to give us, this compound. So we are saying the number of moles is already 0.015, 0.015, and then 483278, and then this should be equal to the mass. Now the mass is 0.9030 over the molar mass, which you don't know. So therefore the molar mass will be given by 0.0930 divided by 0.015483178. Molar mass then is going to be 58.32098.345 grams per mole. So that is the molar mass of this compound. Now let's determine the molar mass from the formula. We have got M hydroxide. Let's go to hydrogen. We have got 2. This 2 is applying to hydrogen and also oxygen. We have got 2. Molar mass of hydrogen 1.008. And then we've got oxygen. It is also 2. Molar mass is 15.9994. And then let's go to this. That is just M. So we're going to use the molar mass of M now. We are not using M itself, but its molar mass. Okay. So at this point, these two are numbers. Let's add their molar masses. 2 times that 1.008, and then 2 times 15.9994, and then we add those two values. We are supposed to find 34.0148. So this 34.0148 we are adding to the molar mass of M, which we don't know. And we know that this value is supposed to give us this value which is here. So go on and say 34.0148 plus molar mass is supposed to give us 58.32098.345. So the molar mass in this case, we're going to take the 34.0148 over the other side, and it becomes negative, and so it will subtract from 58.3, and we are going to find the value of 24.30618348. Okay, so we can also round this off as 24.31 grams per mole. Let's go on the periodic table and check which element has got this kind of molar mass. So the element on the periodic table with this molar mass is magnesium, and so the element M is magnesium. And you can confirm it. When magnesium reacts with the hydroxide, the formula is magnesium hydroxide with a 2 down there. Alright, so look at the last question in this problem. A 1.0101 gram sample of iron hydroxide was mixed with 20 milliliters of 2 molar hydrochloric acid and enough water added to make 200 milliliters of solution A. And then we got 25 milliliters allocant of solution A and titrated it with 14.56 milliliters of 0.1 molar potassium hydroxide. Now I want to find the value of N in the formula. Alright, so same, we're going to start with the second reaction. If you look at the second reaction, potassium hydroxide is reacting with hydrochloric acid. So the number of moles of hydrochloric acid, because hydrochloric acid is present in the second reaction and also in the first reaction, that is telling us that hydrochloric acid is the excess reagent. Number of moles of hydrochloric acid should be equal to the number of moles of what? Potassium hydroxide, and that is concentration times volume. The concentration of potassium hydroxide is 0.1 mole per liter, multiplied now by the volume, which is 14.56. Now convert that to milliliters by multiplying by, convert to liters by multiplying by 10 to the power negative 3. And that is going to give us a value of 0.001456 moles of hydrochloric acid. Okay, from this, which you can see is we only got 25 milliliters of eloquent and titrated. So this number of moles we found is in 25 milliliters. So let's find the concentration if we have the number of moles and the volume. So concentration is number of moles over volume, and the number of moles is 0.001456 moles over the volume now is 25 milliliters. Convert that to liters by multiplying by 10 to the power negative 3. And so we are going to find 0.05824 molar of hydrochloric acid. Now remember all this. We diluted the solution, we added water, and it was 200 milliliters. From these 200 milliliters, we only got a portion. This is the portion that we got. So we can actually find the number of moles in 200 milliliters because the concentration is going to be the same since we are getting the same solution. So the number of moles of hydrochloric acid in 200 milliliters is going to be equal to concentration times volume. The concentration is 0.05824 molar, which is mole per liter, multiplied by the volume, which is 200. Now convert that to liters by multiplying by 10 to the power negative 3. And so what we are going to have at this point is going to be 0.001456 moles of hydrochloric acid. So these are the moles which are present now in the 200 milliliters of solution. Okay, we can also find the number of moles. From here, we've been told the 1.0101 gram sample was mixed with 20 milliliters of 2 molar hydrochloric acid. We can actually find the number of moles of hydrochloric acid initially. So the number of moles of hydrochloric acid initial is going to be given by concentration times volume. So the concentration given is 2 molar. So that will be 2 mole per liter. And then multiply by the volume. Now the volume is in 20. Okay, the volume is 20 milliliters. Convert that to liters by multiplying by 10 to the power negative 3. And so that is going to give us 0.04 moles of hydrochloric acid. Alright, so having found this number of moles, these are the ones which are present initially, and then these are the ones which reacted in the second reaction. So that means if we subtract these which react in the second reaction from these which react in the first reaction, we are going to find the number of moles of hydrochloric acid which remained. These are the ones which are present initially. If we remove this which react in the second reaction, we are now going to find the number of moles of what? Sodium hydrochloric acid, which reacted in the first reaction in that case. We can also do it like, let's determine the number of moles of iron hydroxide in this case. So the number of moles of this iron hydroxide. So we can use two ways, as I'm saying. We can subtract this value from this value. That will give us the number of moles of what? Hydrochloric acid which were present to react in the first reaction. So those moles of hydrochloric acid which react in the first reaction, now I'm going to compare the mole ratio. Number of moles of this over 1 is equal to number of moles of hydrochloric acid over N. But you've already found the number of moles of hydrochloric acid, so you can substitute in and then say over N, and that will give us the number of moles of what? Iron hydroxide. So it is the same process. Let me use this way. Number of moles of iron hydroxide will be given by the mass over the molar mass. Now the mass has been given as 1.0101. The molar mass we don't know because we've got N. we have got an unknown at this point here, so we'll not be able to determine the molar mass. Okay, let's just say this. But we know that from the formula, number of moles of iron hydroxide over 1 is equal to the number of moles of what? Hydrochloric acid over what? Over N. Because that's the number in front of hydrochloric acid, that's N. Okay, now having known this, we've already found the number of moles of this compound which reacted, because this compound was used up completely. This is the number of moles that reacted with the hydrochloric acid. So where there is that value, number of moles of iron hydroxide, we're going to substitute this, and then remember we're multiplying by N. So that will give us number of moles of hydrochloric acid being equal to 1.0101 over molar mass. Remember we are multiplying this value by N, so we are going to put N there. So these are the number of moles of hydrochloric acid which actually did react. Okay. Now, to find the number of moles of hydrochloric acid which were present in excess. So number of moles of hydrochloric acid in excess. In other words, if we say in excess, we are determining the number of moles which reacted in the second reaction. That will be the number of moles of what? Hydrochloric acid initially, minus the number of moles of hydrochloric acid which reacted with what? The iron hydroxide. And the number of moles of hydrochloric acid initially is 0.04. The ones which reacted with the iron hydroxide is these moles which are here, which is 1.0101 N over molar mass. And you know that the excess moles are the ones which came to react in the second reaction. Okay, so they should be equal to 0.001456. So this is true. Alright, before we do this, we need to determine something here before we even do this. Alright. Now, what we have found out here, of course, this is true. This is the number of moles of hydrochloric acid which are present in excess. So let me just clean up a bit. And we know that now this number of moles which are present in excess should be equal to the number of moles of hydrochloric acid which reacted in the second reaction. And what are those moles? Those are the ones which we found now, which reacted in the second reaction like that. Now the number of moles that reacted in the second reaction, let's determine well. Okay. So we should have found something. We found the number of moles of. So number of moles of hydrochloric acid in 200 milliliters. So those should be equal to, now look at this. We have got this number of moles which we found. Okay. We found 0.001456 moles. There's something that I didn't put properly here. Alright. Those are actually not present in 200 milliliters. Those were present in 25 milliliters. If you do the calculation properly, let me just skip it from here. We said the number of moles of hydrochloric acid were equal to the number of moles of what? Sodium hydroxide. And that was equal to concentration times volume. And we use for sodium hydroxide, the concentration was 0.1. And then we multiplied by the volume, which was 14.56. Now times 10 to the power negative 3 to convert it to liters. and that gave us a value of 0.001456 moles. Okay, now these are the moles which were present in 25 milliliters. So so we're going to find first the concentration of this, as we did number of moles over volume. The number of moles is 0.001456 moles. The volume is in 25, so 25 just convert that to liters by multiplying by 10 to the power negative 3. That will be now in liters. So the value that we are supposed to find at that point is 0.05824 molar. Okay, that is 24 molar. So these are the number of moles of hydrochloric acid. Then now we have found the number of moles of hydrochloric acid like that. So this is the concentration of hydrochloric acid. So we're going to go on and determine the number of moles. These of course are the number of moles present in what? In 25 milliliters, and this is the concentration. Now if we punch on the calculator, I didn't punch properly. We said to find now, this is the same concentration. Of course this is present in 25 milliliters. Now we only got this 25 milliliters from where? From the actual 200 milliliters. So now to find that value, the concentration, okay, in other words the concentration is the same. Now we want to find the number of moles of this hydrochloric acid in now the 200 milliliters. We said we are going to multiply the concentration times the volume. This concentration we found is the concentration is only 25 milliliters. Some of you might have realized as we are doing it. So this concentration we are now going to multiply with the volume. Okay, the volume now I want to find, that is 200. So times 200, now 200 times 10 to the power negative 3 to convert it now to liters. Okay, this value we have here is concentration, it's not moles. So just go on and multiply this. This is mole per liter, and then times 200 times 10 to the power negative 3 liters. Now let me repunch on the calculator. I wrote a wrong value on the first press. That is 0.001456 multiplied by 200 divided by 1000. Okay, so the value that we are supposed to find there, let me take it in this way so that we don't get a wrong value again. Alright, at this point we have found the concentration in 25 milliliters. Now let's get to notice that in 25 milliliters, this is the concentration that we have found, and then the number of moles in 25 milliliters is here. So you can just use this method. So to find the number of moles now of this hydrochloric acid in 200 milliliters, what we'll do is we're going to get the number of moles of hydrochloric acid in 25 milliliters. That is 0.001456 moles. Now we're going to multiply, since we only got this portion from what? From 200 milliliters. This number of moles, we only got them. We got this portion of volume from the 200 milliliters. So we're going to multiply how many, in this case we're saying how many 25s are in 200. So now I want to determine how much volume, how much number of moles are going to be present in 200 milliliters if in 25 milliliters we have got this number of moles. Okay, so that is going to give us now 0.01 648 moles of hydrochloric acid. Okay, so that is how we are going to determine the number of moles in 200 milliliters of solution. So those are the number of moles. Now these are the number of moles which reacted in the second reaction. And remember, when we did subtract for this second part, the number of moles that we are finding are the number of moles which are present which reacted in the second reaction also. And so that means these two values are supposed to be equal. So what we are saying is the 0.01648 supposed to be equal to 0.04 minus 1.0101 N over Mr. Now this molar mass is for the iron hydroxide that we need to pay attention to. Okay. So at this point what we can do is I can multiply everything by what is down there so that it doesn't appear. So we're going to have 0.0. Okay, there is another one here. We should check again. There are two ones there. 1164, and then we're multiplying by the molar mass, and that should be equal to 0.04. That also multiply the molar mass, and then minus 1.0101 N. So now at this point I'm going to go on and replace where there is the molar mass. I'm going to replace. Now the molar mass we can find from here. We've been given iron hydroxide like this with the N. How do you find the number of moles? Of course, the molar mass molar mass for this is going to be equal to iron itself. The molar mass is 55.845, and then plus oxygen, the molar mass is 15.99994, and then hydrogen, the molar mass is 1.008. So we're going to add these two values. If we add those two values, we're going to find 17.0074. Now remember, there is N here, so those values are being multiplied by N. So this is the molar mass for this compound. We'll go on and then substitute. So this will be 0.011648. Where there is molar mass, we're going to put 55.845 plus 17.0074 N. And this should be equal to 0.04, and then 55.845 plus 17.0074 again N there, and then minus 1. Okay, let me just write here since there's no space. 1.0101 N. So now at this point we can go on and do the multiplication. So if we cross multiply, we're going to get 0.65048256, and then plus again multiply this by this, we're going to get 0.19810219 N, and over the other side we're going to have 2.2338 plus 0.680296 N, and then now minus the 1.0101 N. So everything that has got N, we are going to take them to one side. So if we take this to one side, so what I'll do is I'll get this and take it that side. I'll get this and take it that side. This will become negative, this will become positive, and then it will add to that other portion. So what we are going to get now is 0.527906195 N, and that will be equal to, I'll get this one and take it the other side of the equation. It will become negative, and so it will subtract from this value which is here, and what we'll get is 1.58331744. Now to remain with N, divide both sides by this value 0.59790 all those values, and then divide also this side by 0.5979 and all those values. We are going to find 2.999240121. Now to find the value of n, this is approximately, it's a whole number, n is supposed to be a whole number, that is approximately 3 if we round off. Alright, and this ends this video. Hope this has been helpful. Remember to subscribe for more videos, and also press on the notification button so that whenever a new video has been posted, you are going to receive it. Thank you so much for watching. Stay blessed.